Good day, everyone. I'm Danica Quinduyos, your reporter at this time. So, our topic for our discussion today is about the second approach in improving a classroom based assessment, which is empirically based procedure. So, let's start our discussion. Our learning objectives. At the end of this lesson, the students can number one, discuss what is empirically based procedure. Number two, compute and interpret the results for index of difficulty, index of discrimination, and distractor efficiency. Number three, demonstrate knowledge on the procedures of empirical approach for improving a classroom-based assessment. Empirically based procedure. Item improvement using empirically based method is aimed at improving the quality of an item using students' response to the test. So it is centered on how well the students perform or responded to the test items. Empirical procedure cover up the results of students' response wherein maa-identify and ma-review kung ano or saang test item na hirapan ng mga student. So test developers refers to this technical process as item analysis as it utilizes data separately for each item. An item is considered good when its quality indices, example difficulty index and discrimination index, meet certain characteristics. For a norm reference test, these two indices are related since the level of difficulty of an item contributes to its discriminability. An item is good if it can discriminate between those who perform well in the test and those who do not. However, an extremely easy item that which can be answered correctly by more than 85% of the group or an extremely difficult item that which can only be answered correctly by 15% is not expected to perform well as a discriminator. The group will appear to be quite homogeneous with items of this kind. They are weak items since they do not contribute to score-based interference. The difficulty index, however, takes a different meaning when used in the context of criterion reference interpretation or testing for mastery. An item with a high difficulty index will not be considered as an easy item and therefore a weak item, but rather an item that displays the capability of the learners to perform the expected outcome. It therefore becomes an evidence of mastery. Particularly for objective tests, the responses are binary in form. Example, right or wrong, translated into numerical figures as 1 and 0 for obtaining the nominal data like frequency, percentage, and proportion. Useful data then are in a form A. Total of number of students answering the item is T. B. Total number of students answering the item right is R. Difficulty index indicates the proportion of students who got the item right. A low percentage indicates a difficult items and a high percentage indicates an easy items. So an item is difficult if majority of students are unable to provide the correct answer. The item is easy if majority of the students are able to answer correctly. An item can discriminate if the examinees who score high in the test can answer more the items correctly than examinees who got low scores. Below is a data set of 5 items on the additional and subtraction of integers. Follow the procedure to determine the difficulty and discrimination of each item. So number 1, get the total score of each student and arrange the score from highest to lowest. Number 2, obtain the upper and lower 27% of the group, multiply by 0.27 by the total number of students. He will get a value of 2.7. The rounded whole number value is 3.0. Get the top 3 students and the bottom 3 students based on their scores. The top 3 students are students 2, 5, and 9. The bottom 3 students are students 7, 8, and 4. The rest of the students are not included in the item analysis. Number 3, obtain the proportion of correct for each item. This is computed for the upper 27% group and the lower 27% group. This is done by summating the correct answer per item and dividing it by a total number of students. And last, number 4, the item difficulty is obtained using the following formula. So, item difficulty is equals to proportion of high group plus proportion of the low group over 2. The difficulty is interpreted using the table. So, the 0.76 or higher is an easy item. 0.25 to 0.75 is an average item. And 0.24 or lower is a difficult item. So, in computation, item number 1, 0.67 plus 0 over 2 is equals to the index of difficulty 0.33. The item difficulty is difficult. And item number 2, 0.67 plus 0.33 over 2 is equals to index of difficulty 0.50. So the item difficulty is average. Item number 3, 2.00 plus 0.67 over 2 is equals to the index of difficulty 0.83. So the item difficulty is easy. In item number 4, 1.00 plus 0.33 over 2, the index of difficulty is 0.50. So the item difficulty is average. And last, item number 5, 1.00 plus 0.33 over 2, the index of difficulty is 0.67. And the item difficulty, it is average.
My name is Joaquin Bernal, and I will be discussing the discrimination index and the structure analysis. Discrimination index, the power of an item to discriminate between informed and uninformed groups or between more knowledgeable and less knowledgeable learners. This is an item statistics that can reveal useful information for improving an item. An item discrimination index shows the relationship between the student's performance in an item and its total performance in the test represented by the total score. It means discrimination index is a basic measures of the validity of an item. So it is a measures of an item's ability to discriminate between those who scored high on the total test and those who scored low. Item total correlation is usually part of a package from item analysis. Getting high item total correlations indicate that the items contribute well to the total score, so that responding item total correlations indicate that the items contribute well to the total score, so that responding correctly to these items gives a better chance of obtaining relatively high total scores in the whole test or subtests. For classroom tests, the discrimination index shows if a difference exists between the performance of those who scored high and those who scored low in the item. As a general rule, the higher the discrimination index, the more marked the magnitude of the differences, and thus the more discriminating the item is. The natures of the difference, however, can take different directions. Letter A, positively discriminating item. Proportions of high scoring group is greater than that of the low scoring group. Letter B, negatively discriminating item, or proportions of high scoring group is less than that of the low scoring group. And letter C, not discriminating item, or the proportions of high scoring group is equal to that of the low scoring group. Computing the discrimination index therefore requires obtaining the difference between the proportions of the high-scoring group, getting the item correctly, and the proportions of low-scoring group, getting the item correctly using this simple formula. D equals RU divided by TU minus RL divided by TL. So where D is the item discrimination index, RU equals number of upper group getting the item correct. TU equals number of upper group. RL, number of lower group getting the item correct. And TL equals number of lower group. Another calculations can bring about the same results as D equals open parentheses RU minus RL close parentheses divided by T, where RU equals number of upper group getting the item correct, RL equals number of lower group getting the item correct, and T number of either group. So as you can see, R divided by T is actually getting the p-value of an item. So to get D or the discrimination index is to get the difference between the p-value involving the upper half and the p-value involving the lower half. So the formula for discrimination index can also be given as according to PAPFAM 2011. D equals PU minus PL, where PU is the p-value for upper group, open parentheses RU divided by T close parentheses. PL is the p-value for lower group, open parentheses RL divided by TL close parentheses. To obtain the proportions of the upper and lower groups responding to the item correctly, the teacher follows these steps. Letter A. Score the test papers using a key to correction to obtain the total scores of the students. Maximum score is the total number of objective items. Letter B. Order the test papers from highest to lowest score. Letter C. Split the test papers into halves, high group and lower group. For an instance, for a class of 50 or less students, do a 50-50 split. Take the upper half as the high score group and the lower half as the low group. For a big group of 100 or so, take the upper 25% up to 27% and the lower 25% up to 27%. Maintain equal numbers of test papers for the upper and lower groups. Obtain the p-value for the upper group and p-value for the lower group. Letter E. Get the discrimination index by getting the difference between the p-values. For purposes of evaluating the discriminating power of items, PAPHAM 2011 offers the guidelines proposed by Ebel and Frisbee 1991 shown below. The teachers can be guided on how to select the satisfactory items and what to do to improve the test. Discrimination index, item evaluation. So under with point 40 and above, we have item evaluation, very good items. Point 30 up to point 39, evaluation item, reasonably good items but possibly subject to improvement. Point 20 to point 29, marginal items usually needing improvement. And lastly, point 19 and below, for items to be rejected or improved by revision. So items with negative discrimination indices, although significantly high, are subject right away to revision if not deletion. With multiple choice items, negative discrimination index is a forensic evidence of errors in item writing. It suggests the possibility of wrong key, or more knowledgeable students selected the distractor which is the correct answer but is not the key option. Unclear problem in the stem leading to more than one correct answer. Ambiguous distractors leading the more informed students be divided and choosing the attractive options. Implausible keyed option which more informed students will not be choose. As you can see, awareness of item writing guidelines can provide cues on how to improve items hearing negative or non-significant discrimination indices. Distractor analysis. Another empirical procedure to discover areas for item improvement utilizes an analysis of the distributions of responses across the distractors. Obviously, when the difficulty index and discrimination index of the item seem to suggest its being candidate for revision, distractor analysis becomes a useful follow-up. In distractor analysis, however, we are no longer interested in how test takers select the correct answer, but how the distractors were able to function effectively by drawing the test takers away from the correct answer. The number of times each distractor is selected is noted in order to determine the effectiveness of the distractor. We would expect that the distractor is selected by enough candidates for it to be a viable distractor. What exactly is an acceptable value? This depends to a large extent on the difficulty of the item itself and what we consider to be an acceptable item difficulty value for test times. If we are to assume that zero point 0.7 is an appropriate item difficulty value, then we should expect that the remaining zero point 0.3 be about evenly distributed among the distractors. Let us take the following test item as an example. In the story, he was unhappy because blank. Letter A, it rained all day. Letter B, he was scolded. Letter C, he hurt himself. And letter D, the weather was hot. So let us assume that 100 students took the test. If we assumed that A is the answer and the item difficulty is zero point 0.7, then 70 students answered correctly. What about the remaining 30 students and the effectiveness of the three distractors? If all 30 selected D, the distractors B and C are useless and the rule as distractors. Similarly, if 15 students selected letter D and another 15 selected letter B, then C is not an effective distractor and should be replaced. The ideal situation would be for each of the three distractors to be selected by 10 students. Therefore, for an item which has an item difficulty of zero point 0.7, the ideal effectiveness of each distractor can be quantified as 10 over 100 or zero point 0.1. What would be the ideal value for distractor in a 4 options multiple choice item when the item difficulty of the item is zero point 0.4? Hint, you need to identify the proportions of students who did not select the correct option. From a different perspective, the item discrimination formula can also be used in distractor analysis. The concept of upper groups and lower groups would still remain, but the analysis and expectations would differ slightly from the regular item discrimination that we have looked at earlier. Instead of expecting a positive value, we should logically expect a negative value as more students from the lower group should select distractors. Each distractor can have its own item discrimination value in order to analyze how the distractors work and ultimately refine the effectiveness of the test item itself. If we use the above items as an example, the item discrimination concept can be used to assess the effectiveness of each distractor. Consider a class of 100 students, then shall form the upper and lower groups of 30 students each. Assume the following results are observed. In the table, we have the distractor, number of upper group who selected, number of lower group who selected, discrimination index. So under the distractor A, it rained all day. We have 20 from upper group, 10 from lower group. Then if we solve the discrimination index, we have 20 minus 10 divided by 30 equals 0.33. Under the distractor letter B, he was scolded. We have 3 from upper group, 3 from lower group. Then if we solve the discrimination index, 3 minus 3 divided by 30 equals 0. Under distractor C, he hurt himself. We have 4 from upper group, 16 from lower group. Then if we solve the discrimination index, we have 4 minus 16 divided by 30 equals negative 0.4. While distractor D, the weather was hot, 3 coming from upper group, 1 from lower group. Then if we solve the discrimination index, we have 3 minus 1 divided by 30 equals 0.07. The values in the last column of the table can once again be interpreted according to how we examine item discrimination values, but with a twist. Alternative A is the key and a positive value is the value that we would want. However, the value of 0.33 is rather low considering the maximum value is 1. The value for distractor B is 0, and this tells us that the distractor did not discriminate between the proficient students in the upper group and the weaker students in the lower group. Hence, the effectiveness of this distractor is questionable. Distractor C, on the other hand, seems to have functions effectively more students in the lower group than in the upper group selected this distractor. As our intention and distractor analysis is to identify distractors that would seem to be the correct answer to weaker students, then distractor C seems to have done its job. The same cannot be said of the final distractor. In fact, the positive value obtained here indicates that more of the proficient students selected this distractor. We should understand by now that this is not what we would hope for. Distractor analysis can be a useful tool in evaluating the effectiveness of our distractors. It is important for us to be mindful of the distractors that we use in a multiple choice format test, as when distractors are not effective, they are virtually useless. As a result, there is a greater possibility that students will be able to select the correct answer by guessing as the options have been reduced. That's all for my report. Thank you so much for listening.